Okay. If you notice on our level 3, we do one where we're going to construct the net of a pyramid. With, the net of a pyramid looks like this, right? That's the net of a pyramid, basically. And we'll do another one where we construct the net of a cone. But we don't construct the net of a sphere. Do you guys know why we don't construct the net of a sphere? Is it possible to construct the net of a sphere?
No.
No, in fact, that's one of mankind's oldest challenges, is taking something like the Earth, right? Which has North America, which looks a little bit like that. And there's South America, and there's Africa, and there's Europe. And then, here's the telltale mistakes. Antarctica is that big, and Greenland is that big. But when you get this map of the world, Greenland always looks like this giant thing, and Antarctica takes up the entire bottom of the map. The reason for that is that this is curved space. So the stuff in the middle flattens out nice and easily. But the stuff at the top has to be expanded because there's nowhere else for it to go. They've got to make this small amount of space look big. So the bottom and the top and the bottom always look really distorted. So the things that are near the North Pole and the South Pole look a lot bigger than they really are. And this is something that people a lot smarter than you and I have struggled with, trying to make a good map that looks like a flat surface. Basically, it's impossible to make the net of a sphere, so we're not going to do it. But we do know how to make the net of a cone, and that's a good challenge. Does anybody have an idea what the net of a cone might look like?
A circle.
A circle? The bottom's obviously a circle, it's true. How many parts do you think make the net of a cone?
4.
4? 4? Are you saying 4 because the pyramid was 4?
Yeah.
The pyramid is 5 actually.
Oh, 4.
2? Okay, I'll go with that. It is 2. Can anyone imagine what the other piece looks like?
Sort of like a U.
A U?
No.
Try to use your imagination, because using your imagination on problems like this can be interesting. Like a half what?
Oh, no.
A half circle? Okay, so like that, sort of?
Yeah.
Okay. Does anybody else have a different idea? Another circle? Just a big circle? A triangle? Okay. These are kind of things I hear a lot. With the triangle, if you just had a two-dimensional triangle, you try to put that onto a cone, what you'd end up with is basically a shark fin sitting on top of a circle. It's not exactly what you need. Some people think of the triangle and they say, well, what if I folded this part around to touch right there? And that would sort of be true, but what you'd end up with is something somewhat unbalanced. As these distances, you'd get it, but it wouldn't be flat looking. Okay, so it's close, but it's not exactly right. The full circle, you can turn into a taco shell. But you can't turn it into a cone. The half circle, now we're getting somewhere. If you were to take the half circle and fold it exactly like this, you would end up with basically this shape. The true answer is half circle or any part of a circle. In other words, it could be a half circle, it could be a Pac-Man. I mean, that's a classic one. Pac-Man. It could even be a little wedge of a circle. Not quite a triangle, but a little wedge of a circle. Because if you folded that over to that, what you'd end up with is a real skinny spire like that. All right. So that's just a little prologue. Just like the pyramid one, it says construct the net, but it also says, or should say, sketch the cone here. Sketch the cone here. So on your worksheet, do I want you doing the sketch or the construction? The sketch, okay. And it's probably wise to start by doing the sketch. So if r equals 6, that means that this is 6. Everybody's got that idea? Yep. And what other piece of information were we given? Were we given the height or the slant height?
The
Slant height.
Slant height. So is that this or is that this?
The right side.
This one, right? Okay, so that's 10 centimeters. What piece of information is missing?
The height.
The height. Okay. And how would you figure out what the height is? Pythagorean theorem, of course. So it's going to be 6 squared plus h squared equals 10 squared. That's 36 plus h squared equals 100. That's h squared equals 64. That's h equals 8. So the height is now 8. I just want to go back to what I was saying before. Doing the sketch really helps you understand what's happening That's why it's smartest to do the sketch first. Not that you have to, but it helps you understand the problem better. All right, so let's fill out all the information that we have discovered. What was the radius here? 6. What was the height? 8. What was the sine height? 10, okay. Now we want to find the surface area. So the surface area is going to be the area of the circle plus pi times the radius times the slant height. Area of the circle means pi times the radius squared. So what is 6 squared?
36.
So it'll be 36 pi plus pi times, is this looking familiar to anybody? Yeah, we already did this problem today. What's the radius? 6. And what's the slant height?
10.
10. All right, cool. So I've got this addition in the middle of my problem. Do I do that first or do I save that for after the multiplication?
After the
After the
multiplication.
multiplication. So what's 6 times 10?
60.
60. So we got 36 pi plus 60 pi. Add that together and it's 96 pi. So there's your surface area. 96 pi. Next, we've got the volume. The volume is going to be 1/3 times the area of the circle times the height. So that's 1/3 times, what is the area of the circle? We already figured it out once. What was it? 36 pi over what?
1.
1, good, times the height, which is what?
8.
8. All right. Once we've got the setup, we look for a chance to reduce. What can we reduce? 336. Okay, so what's 36 divided by 3? 12. So it's all ones on the bottom, so you can forget about the bottom. 12 pi times 8. It's 12 times 8. 96. So it's going to be 96 pi centimeters cubed. Cool. That's everything except for the net. So now we're wondering about the net. Well, what it says is we need the radius to be 6 centimeters for the small circle, and we need the slant height to be 10. So what I want you to imagine is that we took this figure here, this top part, and we cut it. We cut it right there. It would open up so that this would come away one way and the part that's back there would open up the other way. And what you'd end up with is basically Pac-Man. And the radius of Pac-Man is equal to the slant height of the cone. So this would be 10 and this would be 10. And this angle would be 144 degrees. It's not always 144 degrees, but that's a little bit of a longer explanation. Anyway, what I've got here is the circle with radius 6 and the circle with radius 10. So this one becomes the bottom of the cone, and this one becomes the top. What I have here is 2 different radii. This is 10, this is also 10, separated by a gap of 144 degrees. What I can do with this is fold along each radius and make it into a cone. And magically, or mathematically, depending on your perspective, it makes a circle base exactly congruent to the circle that we already had. So there's your cone. Show it to you one more time. This one has a radius of 6, this one has a radius of 10. This one, in other words, is 3/5 the size of this. So I have to remove 2/5 of this circle, and when I do, it's no longer a circle. It's now a cone that is equally matched up with the circle that I already had. So there you have it. There's your net of a cone. Anyone want to guess how tall this is?
8.
8 centimeters. Want proof?
Yeah. Ooh. Is it?
It's not magic, it's logic. I'm telling you. Okay, there you go.